Hi everyone, this is for National 5 pupils of geography studying the Environmental Hazards Unit. Now, in this unit you'll be expected to explain three major things, and that's how earthquakes, volcanoes and hurricanes happen, what the effects of them are, and what we can do to recover from them. Typically, we refer to causes, impacts, and solutions. How they happen is the causes, what the effects of them are the impacts, and how we recover from them we would refer to solutions. An emphasis that you need to have in your revision for this unit is of case studies. That means real-world examples of things that have actually happened, facts and figures. And so I'm going to divide my lessons into three: volcanoes, earthquakes, and then hurricanes. Your teacher may teach you different case studies, and that's absolutely fine, but if you're using this as a revision resource, then I will stick with the case studies that I teach. Okay, so let's get started. Volcanoes. First of all, we need to have a little bit of a background understanding about something called tectonic theory. Looking at the screen here, you can see the text which shows us that the world is very old, and over that time its appearance has changed. You can see on the image on the left that the tectonic plates of the world, that means the surface of the earth called the crust, which is divided into different parts of rock called tectonic plates, is moving. Very famously, Africa and South America fit together like jigsaw pieces because of this process. It's also worth noting that if you refer to the map on the right hand side, that Africa is merely the part of the tectonic plate that's sticking out of the water. It's actually part of a much larger piece of rock known as the African plate. South America too. South America is an enormous continent, but it is nothing compared to the size of the piece of rock that it is in fact attached to. South America is merely the part of the tectonic plate that is visible to us humans above the ocean. Some plates lie completely beneath the ocean. For example, the Nazca plate. None of us can see that because it is a part of the ocean floor of the Pacific Ocean. One of the largest plates, the Pacific plate, is entirely beneath the ocean. Okay, so let's figure out a little bit about how these tectonic plates, these parts of the Earth's crust, how they move. Well, the first thing you're going to need to understand here is something called convection currents. Now, convection currents are all about heat, and if you think about heat, what does heat do? Well, heat rises. And if heat rises, then coolness, it sinks. And hot liquids rise, as you can see happening in the animation, and cool liquids sink. This basic fact allows us to understand that as we go underneath the crust of the Earth, we find that the mantle of the Earth, the layer underneath the crust, is molten. And it is a molten layer full of magma, molten rock. Because the molten rock is liquid, or liquid-like, where it is heated, it begins to rise, as you can see in the animation. As it rises, it reaches the surface, and so it begins to cool down, and cool liquids, well, they want to sink. And as it sinks, it then gets down deeper into the mantle, and so it heats up again, and this creates a constant cycle. That cycle is called a convection cell. If you're interested in wondering why the mantle is molten, that's a perfectly good question to ask, and the reason is because of pressure. As you go down deeper into the ground, the pressure gets greater, and that pressure generates heat, and eventually if you go deep enough, that heat will be enough to melt the rock. These moving cells of liquid rock underneath the crust, they create friction with the crust, and drag the crust around. So the crust is moved because of the convection cells of molten magma underneath the surface of the Earth. This animation simplifies this process somewhat. You can see the inner core, the outer core, the mantle, and the crust. We are, of course, most interested in the mantle, where molten magma is heated and rises before cooling and sinking and returning into the convection cell. This movement of the convection cell creates friction here between the convection cell and the crust, and this is what causes the crust to move. Because the crust can be moving in multiple different directions, you can see this convection cell going from left to right, and this convection cell dragging from right to left. This tears the crust into different tectonic plates, which all move in competing directions. This slightly fancier animation illustrates this in a little more of artistic way. You can see the rising hot rock of a convection cell, and as it rises and spreads, it will pull the surface of the Earth in different directions. Okay. So we've understood that there are different tectonic plates and that the tectonic plates move due to convection currents. Where the tectonic plates meet each other, this creates something called plate boundaries. There are three types: destructive, constructive, and sliding. And it's important to note at this stage, your teacher may use different words for these boundaries. And I won't get into all the different terms there are for the three different boundary types. But I will use destructive, constructive, and sliding, and you only need to understand that those are perfectly adequate terms for your exam. Let's deal with the destructive boundary first. First of all, some reading. I'd like you to pause the video and quickly read through this. This animation takes you through what happens at a destructive boundary. In simple terms, two tectonic plates meet. One tectonic plate is forced underneath the other one, and it's destroyed. And because of that process of destruction, the molten rock that's created finds its way up through the surface of the Earth to form volcanoes. You need to be able to break that very simple explanation down into the level of detail you see here on your screen in front of you. So what's really going on here? Well, the first thing to know is that this is a process called subduction. Subduction happens at a subduction zone. The tectonic plate arriving from the left-hand side here is heavier than the tectonic plate on the right-hand side. Even though it's thinner, it's heavier. As a result, when it bumps into this lighter tectonic plate, the lighter tectonic plate wants to float up above it, and the heavier tectonic plate wants to sink down beneath. Remember that tectonic plates are essentially floating on the liquid mantle underneath, and so the lighter tectonic plates, even though they're thicker, they are lighter. Those are going to react differently to a collision between plates than the heavier, denser plate. So the heavier plate sinks underneath the lighter plate in a process known as subduction. The forces that are created as these two tectonic plates bump into each other are massive. And in this process, the right-hand plate, the continental tectonic plate, it gets crumpled, folded, and deformed. And those folds and crumples are what we would call mountains. and the word for them is in fact fold mountains. Those folded ridges of rock have so many cracks and weaknesses within them because of the folding process that the melting rock happening down beneath the crust in the mantle actually is able to escape up through the cracks that are created and form a volcano. Now, with that understanding a little bit more elaborate in your head, let's return to the text. Two plates collide. The denser, heavier ocean plate sinks underneath the lighter one, and this is called subduction. The subducted plate is melted and destroyed in the mantle. Interesting fact, the molten magma mixes with seawater to form explosive lava. A lot of seawater is dragged down into this subduction zone too. The bending of the crust causes faults. When I was talking about cracks appearing in the crust of the Earth, we really need to use the word fault, a weakness, which allows the lava space to intrude, as you can see happening in the cartoon. The pressurized magma chambers that form can then explode up these cracks and weaknesses to form volcanoes. Okay. That brings us on to looking at constructive boundaries. Now, constructive boundaries happen where two tectonic plates are moving apart from each other. As they move apart because of the convection cells underneath, the surface of the Earth is torn open, and magma spills out to fill the gap. It cools and solidifies into new rock, and then the tectonic plates pull apart again, and the process repeats. An interesting way of thinking about these plate boundaries is as tectonic plate factories, as this is where the youngest, newest rock on Earth is constantly formed, creating new tectonic plate. Those of you with analytical minds will realise that at the other end of this tectonic plate cartoon, there must be a destructive plate boundary. Where the tectonic plate is being created here, it is clearly moving away from the constructive plate boundary. At some point, this tectonic plate is going to bump into another plate and get destroyed at that point. So this is a little simpler to deal with. The two plates pull apart from each other. As they do so, magma spills out. An example of this is the Mid-Atlantic Ridge, the longest volcano in the world, which splits the floor of the Atlantic Ocean in two. Each time the plates pull apart, magma rises to fill the gap, and it creates hardened new rock. And also, interesting point, as this happens over hundreds of millions of years, sometimes you can get a slightly more explosive point on a constructive plate boundary, and that will build up and build up and build up until eventually the hardened rock sticks out above the surface of the ocean. And an example of that is in fact the country of Iceland, which is exactly that process. Iceland itself has two halves, and one half is the tectonic plate that is moving to the west, and the other half is the tectonic plate that is moving east of the Mid-Atlantic Ridge. The last plate boundary is a sliding plate boundary. Essentially, a sliding plate boundary is the easiest one to kind of imagine in your head, but actually is relatively tricky to explain for full marks. You need to communicate the idea that two pieces of rock are sliding past each other, but you need to understand the scale upon which these things are happening. It's quite helpful to try and put your palms together, and rather like in the cartoon in front of you, try and make them slide past each other. It'll help your understanding. As the plates move past each other, because they're made of rock, as you can see in point 1 here, they're not smooth, so they get jammed. As a result, pressure builds up. And if you try and slide your palms past each other, there is a small amount of friction that means that you have to apply energy to overcome that friction to help you slide one hand past the other. Well, the pressure builds up between the two plates, and that pressure gets to a point where the friction that is locking the plates together is overcome. And this results in a big release of energy. The plates suddenly slip past each other. Where the rocks first slip apart, that point at which the pressure overcomes the friction, this is called the focus. The energy moves away from the focus in all directions, and these are known as seismic waves. And where the seismic waves hit the surface of the Earth, where humans would feel it, that is called an epicenter. The epicenter of an earthquake is the first point that the energy released at the focus hits on the Earth's surface. Okay, let's get back to volcanoes though, because that's where we started. The first exam question that you need to answer, or that you may have to answer, is, for a volcano you have studied, explain in detail how they are caused. Now, in the answer that you see on the right hand side, I have taken a bit of a shortcut because I've not introduced you to your case study yet. I will do very shortly, and you should bear that in mind in all future practice that you do. However, if we put that to one side for a moment, this answer here is a model answer for the formation of a volcano. I'm not going to go through the answers with you because I have already done so. If you refer to the previous notes in this lesson by replaying parts of the clip, you'll find the answers. The keywords underneath should help you on your way. Obviously, you should copy this out. You can see the ticks at the end of the sentences add up to 6 out of 6 marks at National 5 level. Okay. So I mentioned a case study, because now what we're going to look at is the impacts of a volcano that we've studied, and this is where your case study knowledge really does become essential. So where you see me refer to dates, places, names, and numbers, you need to assume that you need to know that level of information too. It's really important. It's not enough, and I need to stress this, it is not enough for you to simply remember the name of the volcano. Okay? So we're going to tackle the eruption of Montserrat in 1995. Now you'll see some conflicting pieces of evidence here. The 1995 is when the eruption began. Some dates refer to 1997, but nonetheless the eruption lasted a number of years. So in the case study of Montserrat in 1995, let's just start off with where we are in the world. Montserrat is in the Caribbean. Montserrat is an island nation, as you can see in the map, and it is actually at a destructive plate boundary, as you can see in the diagram here. There's the subduction zone, and this subduction zone has created a chain of volcanoes that are poking out above the sea water, and that creates what's called an archipelago, a series of islands, and those islands are volcanic islands. I would spend some time looking at this map because it contains lots of interesting information. These coloured sections here are the individual pyroclastic flows that the volcano released. And as you look in more detail at the key, for example, you can see the number of settlements that were destroyed. You can see lots and lots of information. So let me talk you through this. On the 18th of July 1995, the Soufriere Hills volcano in the southern part of Montserrat Island suddenly became active. Many people did not even know that there was a volcano on the island. This eruption had loads of really quite serious impacts. What you need to do is have a functional understanding of 6 or 7 of them and be able to quote them in detail. First of all, 5 huge pyroclastic flows destroyed almost all of the southern half of the island's farmland and economy. Industry was destroyed, tourism was destroyed, and farmland was really, really, really badly damaged. The main crop of Montserrat is sugar farming, and this basically wiped out the southern half of the island's economy. It also wiped out the capital city, Plymouth. The capital city of the island was wiped off the map by a pyroclastic flow. If you're hearing me say the word pyroclastic flow and you're mystified by that, make sure that you're asking about that in class, because you should have had lessons on pyroclastic flows. Essentially, a pyroclastic flow is a very high speed, very high temperature landslide of ash and gas and rubble from the volcano. They can move at incredible speeds and incinerate anything that they touch, and after that bury it under meters of ash and rubble. They are an extremely deadly force of nature. Getting back to the keynotes, the main industries of the region are tourism and sugar production. These were both completely destroyed. So there were other impacts too. I mean, this volcano caused mass unemployment on the island and really affected its long-term economic future. Montserrat's capital city of Plymouth was a beautiful city. It was built in the Georgian era, the historical era, and its buildings were very fine examples of architecture. They were all completely annihilated, completely destroyed. A little pause there for thought. If you were to say in the exam, Montserrat's cities were destroyed, well, I'm afraid that's no good. That's not enough information or detail. If you were able to say Montserrat's capital city of Plymouth was destroyed, I'd still want to know a little bit more. What do you mean destroyed? Do you mean totally destroyed, or do you just mean the houses were destroyed? It's the detail that you need to get right with this. So you need to try and draw yourself a picture in your head. 2/3 of the island's population were forced to flee, mainly to the UK, because Montserrat is a UK dependency, leaving fewer than 1,200 people on the island in 1997. An exclusion zone to the south was set up, making the entire southern half of the island inaccessible. This red line here shows you the exclusion zone. The southern half of the island was basically deemed unsafe for human habitation, and so this has actually since become in itself a tourist attraction and has formed part of Montserrat's journey back to being economically healthy. The volcano remains active, and in 2010 the region's airport was buried in a lava flow. The region's airport, called Bramble Airport, was completely destroyed. That has obviously got huge impacts on the economy of the island, the ability of the island to get imports and exports, supplies of medicine, etc. And you'll learn later in this lesson that they reacted to that by building the new Gerald's Airport or the John A. Osborne Airport in the settlement of Gerald's in the north of the island. Spending time with this map is actually a really useful way to revise this material. Pictures help too, of course, and don't just play these video clips once. I'm always telling you that, guys. Watch them a couple of times, spend times with the images, have a look at them. Don't just think that because you've watched this once it's all just going to magically sink in. As you can see, I've noted on the screen where marks are being scored. Impacts of this volcano were that tourism were encouraged. Tourism has been encouraged because people want to see the exclusion zone. Can you hear there the difference between the pupil that just says tourism has been encouraged and tourism is being encouraged because people want to see the exclusion zone? Ash from the pyroclastic flows crushed many buildings. Again, we can talk about crushed buildings in the traditional Georgian old town of Plymouth. Loads of roads and services were blocked. This is quite a famous picture from the time, as it kind of symbolises how people couldn't even make a phone call to get emergency services to where they were at. This photo here is one of the 5 pyroclastic flows hitting the sea. They killed 19 people. That's one thing you can say about the pyroclastic flows. They also deposited huge amounts of ash on the land. And ash is a fantastic fertilizer. So there's a benefit. However, more danger occurred because rain then liquefied all this ashfall to form very, very dangerous lahars. Lahars are sudden flash floods that appear kind of out of nowhere because the ash is so unstable and it mixes with rainwater, and you've got these unpredictable rivers that will appear where rivers normally don't appear. And that can be very, very deadly. Kind of thick, fast-moving, gloopy floodwater can be very, very dangerous. You can see here the ash famously was so heavy it tipped this plane backwards. The ash that you can see built up on the wings is very heavy, and it's heavy enough to crush a building, so it rendered these planes useless, and it closed Bramble Airport. Bramble Airport that was later in 2010, remember, destroyed. And you can hear there how having this detailed knowledge of the case study is going to help you in your answers. Ashfall is a danger to health, but to score the mark, try and pick something out of this list. It causes skin irritations, eye irritations, discomfort with breathing, coughing, nose and throat irritation. And here's a really good one. The ashfall is a danger to biodiversity. If you could tell me a species of animal that was affected, for example, I quite like the name of the scaly-naped pigeon. He sounds cool. That's a name that's going to stick in my head, and I'm going to say to the examiner that the ashfall endangered the scaly-naped pigeon, whose numbers went down 51% after the volcanic eruption. Interesting is how is it that some animals have gone up in percentage, and of course some animals were able to benefit because their competition was wiped out. So the mangrove cuckoo, for example, managed to do very well, presumably because it didn't have to compete for food, because its competitors were very badly affected. Okay, that leaves us now looking at the exam question. For a volcanic eruption you've studied, explain in detail the impacts of the eruption on people and the landscape. A couple of things to focus on here. One, you need your case study. But two, look at this. If you don't refer to people and the environment, you're only going to get 3 marks out of 6 because you've only answered half the question. Always look out for little traps like that. As before, I'm not going to take you through this answer. That's not going to really test you. Instead, you should use the keywords and you should review the lesson that I've just done with you, as the answers are all on the screen or in my explanation. And you should copy that answer into your notes. And that leaves us with the last question, which is, for a volcano you've studied, explain in detail the strategies used to prepare for and reduce the effects of an eruption, for 6 marks. So, strategies used to recover from the Montserrat volcano are basically very straightforward. An exclusion zone was set up to avoid further deaths. We already know that. The new airport, Gerald Airport, was built to replace Bramble Airport for supplies. People were evacuated to the north half of the island, but 2/3 of the island was in fact evacuated to the UK. Specialist rescue teams were sent to recover bodies, as you can see in the photo. The British government offered aid money through the Department for International Development. The Royal Marines were sent to the island to assist in the recovery. A ship called HMS Southampton was dispatched to assist with supplies, and the activity of the volcano is monitored by the Montserrat Volcano Observatory. Now, clearly you need to spend time with those notes, but can I give you one piece of advice? Of all of these, the last one is the most important, because if we refer back to the question, explain in detail strategies used to prepare for and reduce. In other words, we need to know what are we doing before a volcano erupts, and then what are we doing afterwards. And this last one is something that is constantly ongoing and therefore counts as something we're doing before an eruption. And it's very important that you have that balance. So make sure that you're focusing on that last one, and then try and remember as many of the other ones as you can. Okay, the next lesson is about earthquakes. I'll make that a different video lesson, and I'll see you then.